Major Norway earthquake. A major earthquake just struck Norway, and now one of the nation's few volcanoes has a theoretical chance, keyword theoretical, of soon erupting. The earthquake in question struck at 3:33 a.m. local time on March 10, 2025 near the remote but inhabited island of January Mayan, 515 kilometers or 320 miles north of the Arctic Circle. As the ground rapidly shook back and forth for approximately 15 seconds, it is likely that some form of damage occurred to existing structures, with multiple reports from the island indicating MMI-8 shaking was felt in two of the island's settlements. You might be wondering how these people could have reported ground amplification MMI-7 and 8 shaking if the contours they were on suggests only MMI-5 or 5.5 shaking. The simple answer is ground amplification. Confused? Well, when an earthquake wave passes through different rock units and materials, they do not move in the same way. Any materials or rocks which are quite solid and dense will cause a seismic wave to speed up and have a lower amplitude wave, while anything not too solid such as sediments, or lightweight such as clay minerals causes the seismic wave to slow down and increase in amplitude, meaning anything built on the latter will experience far stronger ground shaking. And, what do you know, while yes the entire island is volcanic, the three inhabited settlements are constructed on highly sandy volcanic rock aka sediments, hence the ground amplification. However, due to January Mayan currently being largely inhabited by military personnel, we are unlikely to hear any reports if there was any damage. The earthquake which struck geologic setting was a classic example of a purely tectonic not volcanic left lateral strike-slip fault suddenly moving along a west-northwest to east-southeast trending fault line. This fault line is known as January Mayan Transform Fault, which accommodates the motion between segments of two mid-ocean ridges that act as divergent plate boundaries. But wait, Geology Hub, if this was a purely tectonic quake, why might it have a theoretical chance of triggering a volcanic eruption? The answer to this is that under specific narrow circumstances, if a volcano was already fairly close to erupting, a major nearby earthquake can cause enough motion within an underlying magma chamber that it can initiate an eruption early. While there is no uniform proven rule set involving how strong the ground shaking must be to do this, I have found that MMI-5 shaking seems to represent the minimal theoretical limit. Since the Beerenberg volcano that last erupted in 1985 experienced MMI shaking where its magma chamber is presumed to be of between 6 and 7, this could theoretically end up triggering an eruption. There are a few examples of major earthquakes triggering volcanic eruptions, although the time it takes to trigger an eruption can go as long as 9 months in my sample size. This seemingly happened twice before at the Beerenberg volcano, in both 1973 due to a magnitude 5.1 earthquake and in 1985 due to a magnitude 5.0 earthquake. However, I want to note that these two 20th century earthquakes could have theoretically been volcano-tectonic caused by already rising magma. However, if we assume this wasn't the case, what percentage of these close magnitude 5 or larger earthquakes have triggered eruptions in historical time at the Beerenberg volcano? Only 7.14% of the time or 2 out of 28 historical occasions. In other words, in all likelihood the Beerenberg volcano isn't going to erupt, although it theoretically could in the short to mid-term future. But, for fun, let's just hypothetically assume typical eruption Beerenberg does soon erupt. What might happen? Presumably, a swarm of earthquakes followed by an explosive eruption from a vent near the edge of the island. While this could create a tough ring or tough cone in an explosive eruption, what is more likely is that one or more cinder cone vents form and intermittently eject ash, occurring alongside the eruption of basalt lava that creates a lava delta on the coastline. However, I want to stress this once again, the odds of an eruption happening historical eruptions